Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over another example of how to apply Dalton's law of partial pressures to solve a problem. So let's get into this. So in this problem, we're told that if an 85 milliliter light bulb contains 0.140 grams of argon and 0.011 grams oops, I forgot, that should be nitrogen, right? So that should be N2 at 20 degrees Celsius. What is the total pressure of the mixture of the gases? Okay, so in this problem, we want to find pressure. We're given temperature, we're given an amount of gas, and we're given the volume as well, the volume of the light bulb. So this means that we can use the ideal gas law to convert the amount of gas into pressure. But in order to do that, we're going to have to convert the grams into moles. So that's the first thing we want to do. So we're going to take the 0.140 grams of argon. So 0.140 grams of argon. And we're going to need the molar mass of nitrogen. So if we look that up really quick. So argon, argon. Did I say nitrogen? I meant argon. Argon is 3995. So we have grams of argon over 1. We're going to use the molar mass. So on the bottom, we're going to have 39.95 grams of argon. And on the top, we'll have 1 mole of argon. And then grams cancel out. We got moles. And when we do that, we get 0.00350. 0.00350 moles of argon. And then we do the same thing with nitrogen. So here we're going to have 0.011 grams of nitrogen over 1. And then we're going to use the molar mass. That's like 14.01 if I remember correctly. Yes, this is 28.0134. Because we have 2 nitrogens, it's 14.01. About for 1 nitrogen, since we have 2, it's going to be 28. We're going to have to double it. 28 point, what did I say? 0134. So 0134 grams. Grams of N2, and that's going to be 1 mole of N2 on top. So grams of N2 cancel out, left me with moles, and when I do that, I get 0.00039. 0.00039 moles of N2. So now I have both of my amounts of gas in moles. Now I can use this. Now I can use this in the ideal gas law. So let's make sure that our information is in the right units. So we got 85 milliliters. We're gonna have to convert that to liters. So 85. So we have 85 milliliters, and we know that 1,000 milliliters, 10 to the 3 milliliters, is equal to 1 liter. So milliliters cancels out, and we get 0.085 liters. Okay, and our temperature is in Celsius, so we need to convert that to Kelvin. So we're going to do 20 degrees Celsius plus 273.15 equals, and that's going to be 293.15, and that's going to be Kelvin. Okay. Now for sig figs, we have to be careful because when we're adding and subtracting, the number of significant digits in your answer should be the same as the answer with the least number of decimal places, or the answer that has the least precision. And so here we have one digit here, so the 2 here is going to be, well, we have a 0 here, so this could be our last digit. So this is the ones place. This is going to be the tens place. And so, but this one has the hundreds place, so we would keep it to the ones place. So the last digit would be in the ones here. So that's, well, I'll put a line there to indicate to myself that this is the last significant digit. So when we use that in our calculations, we're not going to get a rounding error, or we're not going to make a mistake with regard to sig figs. All right, so I've got the temperature in Kelvin. Is there anything else I need to do? No, that's it. So I've got everything ready. Now I can plug everything into the ideal gas law, and that's it. Now, when I use the ideal gas law, I'm going to use the ideal gas law. I'm going to plug in the temperature, the volume, and the moles, and I'm going to solve for pressure. Now, there's 2 ways you can do this. You can do each gas separately. You could plug in this number of moles with the temperature and pressure and find the partial pressure of this gas, and then do the same thing, add this mole of this gas to the temperature and pressure, plug that into the ideal gas law, and you'll get the partial pressure of this gas. And then according to Dalton's law of partial pressures, you just add those 2 partial pressures together to get the total pressure, which is what we are being asked for. That's one way to do it. Another way to do it is to just add the moles together and get the total moles of the gases, and then plug that into your ideal gas law equation, because the total moles is going to give you the total pressure. So we're going to go ahead and do that, because that kind of lessens the number of calculations we have to do. So we're going to go ahead and add these together. When you add these together like so, well, I'll just write it here. So we're going to have our ideal gas laws, PV equals nRT, and we're going to solve that for the pressure, the total pressure. So total pressure is going to be equal to nRT over the volume V. So N is going to be total number of moles. So total number of moles multiplied by R multiplied by T over the volume. So we could just go ahead and plug that in. So the total moles is going to be the 0.00, and we're going to add these together. So I'm going to get 389. So that's going to be 389 moles multiplied by R. So R in this case is going to be 0.08258, and that's going to be liter atmospheres. Let me make this clearer. 5.8, and that's going to be liter atmosphere. Oops. Again, let me make that clearer. It's going to be liter. Here, let me give myself some room here. So I'm going to write it down here. So pressure total is equal to the total number of moles, which is again adding these together. So 0.00389. 0.00389 moles, and that's going to be multiplied by 0.082 0.2058, and that's liter atmospheres over Kelvin mole. And then we're going to multiply that by T, the temperature, which is 293.15. So that's going to be multiplied by 293.15 Kelvin. We'll put a line under the 3 to remind ourselves that that is the last significant digit in that measure. And then this gets all divided by the volume, which we have here. Where's the volume? Right here. Nope. Where'd it go? Oh, right here. So 0.085 liters. 0.085 liters. So let's make sure our units cancel out. So moles cancels out with moles. Kelvin cancels out with Kelvin. And liters cancels out with liters. And we're left with atmospheres, which is a pressure unit. We're looking for pressure. So now all we need to do is calculate the amount of pressure. And when we do, we get 1.1 kilopascals. So I'll write the answer up here. So we get, this is equal to 1.1, atmospheres. Did I say kilopascals? No, 1.1 atmospheres. If we wanted that into kilopascals, that would be equal to 1.1 times 10 to the second kilopascals. Now, for the sig figs, for those of you interested in sig figs, our answer should be the same, or our answer should have the same number of sig figs as the measure with the least number, and that is this number here with 8.5. So that is 2 sig figs. So we are having 2 sig figs in the answer itself. And that, ladies and gentlemen, is how you use Dalton's law to find the total pressure of a mixture of gases. And so with that, if you enjoyed this video, if you learned from this video, if you got anything from this video, please like the video, share the video with your friends, hit that like button. Also, subscribe to my channel. Subscribe to my channel, please. And make sure that you click the notification bell. And when you do, make sure that you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section, please. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you want me to go over for you, I would love to do that. If you have a topic you want me to go over, I would love to do that. Thanks for joining me and have a great day.